In October of 2016, a group of gamers released code that leveraged vulnerabilities in IoT devices, specifically surveillance cameras. The cameras were white-labeled, meaning that one factory could produce vulnerable chips that went into many different brands of surveillance cameras. Gamers are, well, competitive. And in a world of gaming, if you can take your opponent out online, you get ahead. So what started as code to do just that, knock an opponent offline, blew up in the real world. Suddenly, the code, which took advantage of a vulnerability in a protocol, could be used against surveillance cameras. And someone did just that. And instead of taking a gamer offline, they took Dyn, an internet provider that supported brands such as Twitter and Netflix. Not only that, they covered customers along the eastern swaths of the United States. They all suffered a massive denial of service attack from bots on IoT devices, on surveillance cameras. Mirai was the first major attack by a device-driven botnet, as hundreds of thousands of surveillance cameras, each with internet connections, were leveraged. Mirai lives on today, with variants causing local attacks. The thing is, Mirai is not alone anymore. And in a moment, I'll introduce you to a world of active cybercrime fueled by devices in your home and in our world. And in the case of BADBOX, too, there is no patch. There is no easy fix. This is a story about cybercrime and how it's blurring the boundaries between humans and bots when it comes to click fraud. I'm Robert Vamosi. This is Error Code.
So I am Gavin Reid. I'm the CISO of Human Security.
I'm Lindsay Kaye, and I'm Vice President of Threat Intelligence here at Human.
Okay, it might be hard to discern exactly what Human does. They look at devices out in the field, IoT, OT devices, and they discover ways that criminals are using these devices for automated attacks and for profit.
And at Human, we're tackling sort of a different kind of cybercrime. And this is one that blurs the line between bots and humans, automation, intent. And we protect organizations. We're like a platform that protects other large platforms from these sort of automated attacks, right? And of course, now with the advent of, agentic and the bots that actually can do some level of decisioning, things have sort of ratcheted up a lot. So we're in line with, the major platforms that you're familiar with, that you're probably using on a day-to-day basis. And so we have to not only be able to identify if it's human, if it's not human, what the intent is, where it's going, what it's doing, but we have to do it kind of at the speed of light, right? Because, no one wants additional latency.
So I am the person who runs the team that is responsible for this research in coordination with our research team, who is more kind of a data science approach.
Gavin mentioned agentic AI. How exactly are these agents fitting in? Is Human using AI to assist with intelligence gathering, or is Human combating against AIs that are perpetuating whatever types of fraud they're looking at?
Yes, and yes. So like many companies in the space, we have a long history of algorithmic development using machine learning. And so, of course, AI and agentic AI has allowed us to do some different things with that. But at the same time, those same customers that we protect against automated attacks, we've had to pivot a little bit because not only do we need to be, the expert at bad bots and being able to identify and protect against them, but we also need to have give our customers that same level of visibility and sort of trust in the good bot. So we've really, as an entire company, sort of pivoted against one that was mostly, look and block to one that now can decide, if it's an agentic AI bot, what do you want to allow that bot to do? Is that bot okay with scraping your site? Is it okay with creating logins? Or do you not want that? Is it okay with logging in and buying stuff and using credit cards? We have to get like much more into the nuts and bolts of what the bot is doing, and whether we want to enable that, and monetize it. We have partnerships where people, if you're a content provider, you may want your data to be scraped, but you feel like people should pay for that. And, same with these large language models, they live off of the data that they're scraping. That's what really makes them smart. It's all the, human data that's put inside there. And so there is obviously a much sort of bigger pull on sites where it used to be, an individual would log in and look at, maybe Atlantic Monthly and read some articles. Now you have bots that are doing this continuously 24 hours a day, 7 days a week, and the business model is shifting.
So I imagine just determining that humans are doing fraud, that's one thing. But now you're entering into the world where agentic AIs and so forth are doing bad things as well. How does Lindsay differentiate? Is she looking at how fast the keystrokes are committed, or where the input is coming from? The traditional things? Or does she have to look for new tools today to detect the AI?
So one of the things that we have is a whole different set of detections that human uses to determine whether it's a bot or a human. And historically, we've been doing that for a long time. But now that agentic AI and all those different AI tools are coming out, so you don't just have agentic AI, you have crawlers and scrapers and things like that. So being able to kind of use what we have learned from how do we, tell if something's a bot or a human, now we have to kind of build upon that and understand how are these AI agents and how are these AI tools doing crawling and scraping? So some of the research that we've been focusing on more recently is really trying to understand just that. So looking, for example, at, are threat actors trying to emulate popular AI tools in order to conduct different types of fraud, as well as if a threat actor were to be using AI agents to do fraud or any sort of cyber attack, what does that look like? And humans data really kind of allows us to sort of start understanding some of that. I believe we have a couple of research pieces where we've covered those topics, as well as one that is going to be coming out in the future that I think really kind of let you see sort of the similarities and differences between general bot activity, AI-related bot activity, and AI agent bot activity.
So when I think of bots in this space, particularly device-oriented bots, I often think of Mirai. So what types of fraud are committed with, say, BADBOX?
So I think Mirai was one of the first examples that really made, the general public in 2016 understand, what is a bot? What is a botnet? Oh my God, it's this thing that's out there. But the one that we have most recently uncovered, at least discussed publicly right now, is BADBOX 2.
So I just have to ask, when naming threats, is this something that was in the code itself, BADBOX? Or was it referring to the fact that it used devices?
So oftentimes you're right. We do try to name threats after the different sort of identifiers in the code or something that would make sense. But here, very simply, bad boxes, these were boxes and they were bad. So while it is not necessarily kind of the most creative origin story that we've ever had, we've had some really great ones. It is, in fact, kind of how we named it. So originally with Peach Pit, which was the ad fraud component of the first BADBOX campaign, there was an identifier in the code that lent itself to using the word peach. So that was Peach Pit. With BADBOX, however, that was the name that, since we used the first one, it really just got, so much coverage and people were excited about that name. And it really does very aptly explain what exactly you're dealing with these bad backdoor boxes that we kept kind of rolling with it. So this is a build upon the original BADBOX research we did. And in case you're not familiar with that, the general premise of that included all of these Android open source project devices that had backdoors installed on them. So these were things like CTV devices, projectors, other kind of these lower end tablets and phones that sometime between when they were created and when they were actually purchased by the public in brick and mortar and online stores that you can probably think of, a backdoor was installed on them. And this backdoor enabled the threat actor to do different types of fraud. So in the original BADBOX, we focused mostly on the ad fraud module called Peach Pit. And I believe we found about 74,000 suspected BADBOX devices. So fast forward a couple years, threat actors went away and now they came back. So that helped us find BADBOX 2. And BADBOX 2, we found over 1 million devices that we believe have a variety of the backdoor installed on them. So some differences now include different types of fraud. So just a couple include click fraud, two types of ad fraud, and then creating and operating a botnet with this device, including providing residential proxy services. So other threat actors can buy access to conduct their own attacks, as well as several different types of backdoors. So in the original campaign, we saw just one called Triada, but now the threat actor has more complicated, more complex, and then just overall more backdoors.
This is important. This crime is spreading because it's using something known as residential proxies. Well, what's that? Well, it's that cheap smart TV that promises you all these premium channels for a low, low price. I mean, it's got to be illegal.
There's a big market of selling things that help, these fraud actors, make their multi-million-dollar fraud deals. There's a number of different sort of components, and one of them is residential proxies. And these go from the maybe slightly sketchy to the almost 100% sketchy, because there will be some people that say, oh, there's a use for residential proxy. I want to see what my site looks like, from all over the world in different residences throughout the world, and I can do that. And so there could be some potentially legitimate use, but much more it is fueled by illegitimate use. And going back to what I said earlier about you have with this device that's your house, and most of the time it's doing normal things, and occasionally it does something bad. This is very, very useful if you're sending spam, if you're doing ad fraud, whatever type of fraud you're doing. A big proponent of it, like most of the stuff that we see, ends up now being funneled through residential proxy. So it may start in a cloud-based service in China or Romania or whatever, but when it actually contacts you or the site that it's doing the fraud, it's actually coming from a residential proxy network. And these networks can be connected TV devices like the BADBOXes. They can be your phones. They can be your laptop. You've downloaded this app that allows you to VPN wherever you want for free. But what they don't say is that they're also setting you up as a VPN. And so, or if they do, it's very deep in the user license agreement that you never really read. And so, to answer, even another one of your earlier questions, how much of this fraud do you see? Like when we sit on these residential proxy networks, which we did with BADBOX 2, we saw it all. Like literally every time you would see some sort of major hack show up, on the internet or people talking about it, we'd seen components of it run through these residential proxies because they're so widely used. So this became just a huge, way that they could make money. That's what they pivoted to. And we knew that we can't really stop that as easily. And so we took a slightly different tack with BADBOX 2, and working with some of our industry partners, we worked to get the command and controls that were managing all of these BADBOXes sinkholed, because those, once we shut them down, they could no longer access and send new instructions. So that they would carry on with their old instructions for a while, but eventually they got disconnected, delinked, and we see now millions of these boxes connecting to these sinkholes that, through industry partners, again, like the Shadow Server Foundation. They were really great at working with us. We got the infrastructure that protects or that manages these systems completely shut down.
Okay, I'm interested in the malware being on there. And I'm going to use Mirai as my basis because, as I understand, there was a vulnerability and the code was added to take advantage of that vulnerability. Is something like that going on here?
So with Mirai, you had your kind of version of the malware that was able to find other IoT devices, try default admin passwords, log in, and sort of self-spread. So BADBOX is a little bit different. So you do have that same concept of a backdoor itself, but it can't at this time spread to other devices. So the way that we believe that these devices are being infected is sometime at the factories. We believe that someone is installing these backdoors on the device itself. So it's not necessarily a vulnerability per se. It's something that is a modification either in the firmware or in BADBOX 2. What we saw is there's several different kind of app level backdoors as well. So in addition to the backdoor being installed at the factory, you can also kind of get this backdoor installed on your device at sort of that application level, really any way that you can think of that people get malware. So drive-by download, malvertising, clicking on the wrong type of link. So they've really kind of diversified it that way, but it's a little different from Mirai because there isn't that sort of self-spreading notion to it.
So with a network attack, you could always put in security controls. You can block it. When we're talking about devices in homes, what sort of mitigations are possible with that?
Yeah, so it's really hard for the end user to know that their box has been commandeered by the bad guys. And that's particularly while they're doing it. If you think of a spread of millions of these devices, and they're global, right? And so if you're a bad guy and you say pivot to using one of these devices for a few minutes to do whatever fraudulent attack you'd like to do through the residential proxy network, the majority of the traffic on that box is normal traffic. It's you watching Netflix. It's you going and watching the sports, and so there's a very small amount of it that is actually doing the fraud traffic. So it's really, really hard for the end user to sort of figure that out or to mitigate it. And that's why one of the reasons residential proxies are so successful is it's hard for even the good guys that are trying to mitigate these things at a high level to know, okay, well, 99.9% of the time there's good stuff, but occasionally there's some bad stuff there. And how do I know when to block and when not to block? And this is where this is why you have companies like Human Security that, we've lived at sort of modeling this over the last 10, 15 years. So we have really good data to use in our machine learning models to be able to help understand when good connections go bad. To answer your question, it's really hard. The only way you can mitigate this is by taking the device and, putting it in the trash, right? There is no I'll just run this, service pack, or I'll install some antivirus on it and it'll be fine. It doesn't work, especially for these devices that have been hard, coded firmware. There's no way you can fix that. Like, as an end user, you don't know how to wipe out firmware on your connected TV device and find the firmware for the very specific chipset that you have and then reinstall it. You would need really specialized knowledge and tools to be able to do it. So there isn't any fix. And then what we have been doing is, because there isn't any fix, we've been, the mitigating factors that we've been looking at is, okay, well, how do we dismantle the infrastructure? With BADBOX 1, that was turning down how they were monetizing it, which was the Peach Pit model that Lindsay talked about. We had millions and millions of these fraudulent ads going through that were basically just making money for these guys. And so what we did is identified it. We worked with our industry partners. Where does this ad fraud, come from? Who's instituting it? Who's doing it? So we could shut down the entities, and so they could no longer do it, and we could block it, and we could make sure that, okay, we can't stop them from owning these bad boxes, right? But we can stop them from making money. And so as soon as we did this literally, and there's a bunch of modules on this device. When we did this, literally a week later, we saw that the command and control centers basically went and wiped them all out. So they became normal connected TV boxes. And I think at that point they realized someone's paying attention, the game is up, and they didn't want it to connect back to them because they want to do it again because they're making millions of dollars out of this. So they just, basically wiped the machines of all the badness that they put on. So even though we couldn't do it, they could, because, they're controlling these things at the root level. And they know what to, they put it on there, they know what to do. Now with BADBOX 2, it was a little different. We thought, okay, this isn't, they've got multiple different models for monetization. As Lindsay very correctly pointed out, we could block them and we could identify them really easily because everything was sort of hard coded into the firmware. And once we found out the IOCs, we could share those and get them taken care of. So what they did is said, okay, one methodology for getting malware on these, one methodology for monetization isn't going to do it anymore. We're going to do many of these. And so even if they block one, we can still do another. And as we did exactly that with adware, they just really pivoted to selling these as residential proxy services. And are you Are you aware, or your audience aware of residential proxies?
So earlier it was mentioned that there are primarily two types of ad fraud.
So the first one was involving hidden ads. Very simply, hidden ads are ads that the user can't see, but that are claiming to be displayed. So that's considered fraudulent because people are being charged to show the ads, but no one's actually seeing the ads, which is not intentional. So this ad fraud component was responsible for 5 billion fraudulent bid requests per week when we caught it. So when we caught BADBOX 2, we believe we caught it during sort of a testing stage, as evidenced by seeing the word test in some of the malware and other indicators that, they're still kind of testing things out, spinning them up. So while this doesn't seem like a whole lot of fraudulent bid requests, this is something that we think could have gotten bigger had they been able to fully actually, productize their campaign. But the way that this happened was through something called the evil twin method. So this is something that we had seen once before with a campaign that we had uncovered and disrupted called Confetti. But the basic premise is that there are two sets of apps. So a decoy twin and an evil twin. So the decoy twin are these benign applications hosted in the Google Play Store. And they don't do any sort of fraud. They just simply have to exist. So they have sets of identifiers, so ad identifiers, package names, other things like that, that then the evil twins can actually take. So these evil twins use those identifiers, and they're the ones actually doing fraud. So the way that you get an evil twin on your device, you cannot get it from the Google Play Store. You get it from, different ways that you can be infected, right? So any sort of way to download malware, but very important, it is not in the Google Play Store. So this is where all the sort of hidden ads fraud was coming. And then the second type of ad fraud was hidden web views. So really what this is very similar to a hidden ad, but it is a web view. So if you ever have used some sort of, application on your phone and there's some sort of, internet access to it that's not through the actual browser, so goes to some sort of URL, displays it in the app, that's simply probably a web view. So a hidden web view is a web view that the user can't see. So what the device did was in the background without the victim's knowledge is it would have one of these hidden web views and it would actually navigate out to a set of HTML5 games. And what it would do is look at the ads there. So pretty much how this works is that the user would be using the device. They would have no knowledge that this is actually happening in the background. So these games on these HTML5 game websites, they had ads popping up every couple seconds. Like there is no expectation that an actual human would have eyes on these games. That would be a hugely frustrating experience, I'm sure. If you're trying to play a game and ads came up every couple of seconds, it's just unplayable. So we believe that these games existed solely for the purpose of conducting ad fraud with these devices viewing these ads.
So Lindsay mentioned games, the hidden games. So no human would tolerate going through all those ads. So the point being, for every click, there's monetization. Well, what's the game here? No pun intended. What is the goal of the criminal organization if they're getting clicks on those ads?
So this is potentially a way for cash out. So generally when somebody views an ad, that's worth some kind of numbers of cents. But once somebody clicks on the ad, that's worth a whole lot more. So we saw a click fraud component to this as well. So that's very similar. Again, there are these websites that the devices would visit in the background and click on the ads there. But this is some kind of cash out mechanism. So if you are having your devices kind of go and then view these ads, then the criminals are actually kind of making money off of that. So if that makes sense to you, partially we believe that the click fraud component and at least some of the ad fraud component was the way that the threat actors were monetizing the other parts of the operation. So as you kind of understand, this is a whole cyber fraud ecosystem. There's a lot of components to it, a lot of pieces, parts, threat actor groups that are all sort of interwoven here. So if you consider the ad fraud portion, a great way for them to make money and potentially is a way that they can fund the other parts of the operation, that's how I'd encourage you to look at it.
So are these ads legitimate?
They are ads, but whether or not they are good ads, they are not good ads, right? If that makes sense. So it's like in order to cash out, then there has to kind of be these games that have these ads that need to be looked at, but no actual people are going to look at them. So they're never intended for actual humans, if that makes sense.
I want to clarify, when we say cash out, are we talking about like virtual money or are we talking about fiat?
So Gavin might be able to explain this a little bit better, but the basic premise is that there is money that they need to then take from point A and put to point B. And if you view your ads and you're hosting your ads, then you can kind of, if that makes sense, then you can sort of, yeah.
Yeah, so I think Lindsay got it perfect there. We saw with, we've suspected that these have been used as a way to wash money. We don't have actual, the financial transactions behind to prove that, but we do see exactly what Lindsay's saying, that people are buying and paying themselves off with, one form of fiat and getting, another form of fiat out of it. So that, it's one level abstracted. At the same time, they're also they're putting these spaces up for anyone to bid on. So legitimate people can bid and say, oh, I want an ad on that website. I'm going to spread my ads everywhere. And so they are getting a mix of legitimate ads in there of people that are just, the advertisers themselves are getting ripped off, which again is sort of where, our company comes in. These advertisers, buy us to protect against that sort of stuff happening.
So Lindsay's team, they come up with the BADBOX evidence. It says it's out there. This is real. What type of disclosure process is involved here, since we're talking about a lot of different devices out there?
Well, it's hard, right? If they're in the millions, they're typically, another question would be, why did they buy these in the first place, right? And that'll help you understand maybe how difficult it is to stop it. But instead of buying an Apple TV for $95, they buy this, Android open source black box thing, and it's like $30 or $25. And so, often they're being sold in areas where people just don't care a lot. Also, we saw a lot with BADBOX too, where they're being packaged and resold as kind of pirate boxes, where you buy the box from this strange third party and it's preloaded, and it like shows you all the Netflix and all the all the different sports channels and all the movies and everything, and you pay one low $5.99 a month and you get everything globally, worldwide on this box. And so they're already they're purchasing this box specifically because it's like super cheap, right? So they don't necessarily, there's no like registrar of everyone who owns one of these boxes, and there's literally hundreds of different manufacturers behind them, and then sub manufacturers or people that buy them and resell them underneath them. And so we reached out to the normal folks that we saw these. I'm not going to name them, but you can imagine who they may be. And they were concerned and they didn't like it. And they said, show us, like, where is this for sale, say on my website, and we'll get these taken down. And it just became, there was so many of them that it was really, really hard for us, so what we do, like we did this, in fact, this got pushed by, I think we presented on this at a security conference. And after presenting, the ETF sent a note to the FCC and said, hey, what's going on here? Why aren't you doing something? And then some of those same people who may have not been as interested in following up, like followed up and said, we want to get every one of these and make sure that we're no longer selling them. And we helped them, and they took them all off, right? Literally 2 weeks later, the same boxes were on different seller, and they had, there was like I think one of the main boxes was like a T95. Now, again, not all T95s were bad, but a lot of them were bad. And so these sellers just changed their seller name, and they would have the same box, the same advertisement, but they just airbrushed out the T95. And this is now a connected TV box. So it's an ongoing problem, right? Because we have folks in areas that maybe care a little bit less. Like if these were all being manufactured and sold by a US company, we could probably do exactly what you said. But because it's so diversified, we had to think of other ways that we could just make it not as, they wouldn't be able to make as much money out of it. That's the only thing that really stopped them from doing it, or dismantling some of the infrastructure so they could no longer monetize the boxes themselves.
So Human talks about shutting down the infrastructure. And we talked about like not selling these devices and so forth. But is there some sort of root vulnerability or something that can be addressed or mitigated?
So this isn't necessarily something that was built on the back of a vulnerability, right? So somewhere in the factory, someone is maybe associating with a group that is installing these backdoors on the devices between when they're created and shipped out. So that's not really a vulnerability, more like a bad set of threat actors, right? And then you have this sort of second component, which is a little bit more controllable in that, people go out and they download apps from all sorts of third-party marketplaces, potentially ones that, may or may not be sketchy. Then you have sometimes people click on suspicious links. So while obviously we can't blame victims for installing these things on their devices, that's something that, with a little bit more education and just kind of knowledge of the fact that that is risky. We always talk about, only downloading apps from official app stores, being pretty careful about what you click on. If your device is behaving funny, consider chucking it. That's kind of the other aspect of it. So that's not perfect, but that does sort of help address at least that component of it.
And this is limited to the Android universe.
So specifically only Android open source project devices. So these are the ones that are not Google Play Protect certified. They're, as you are aware, Android is an open source operating system. People can kind of just install it on devices that they want. So to really separate out these devices, the AOSP ones from the official Google ones, it is only the AOSP devices.
So Mirai, it's still around. It's not going away. There are projections that BADBOX 2 is going to be around for a while as well.
So one of the biggest things I believe that keeps Mirai around is the fact that Anna Senpai actually open sourced the code, and now we see people pivoting on it, making new versions of it, right? So that's kind of one of the biggest pieces of what makes Mirai kind of come back and be successful. In addition, if you look at BADBOX, we don't see that open source backdoor. We see the threat actors pivoting on the backdoor, making new versions of the backdoor. But outside of that, it's something where we demonetize them the first time. We've demonetized them again. They're always going to come back, right? A cyber criminal's job is to make money. They want to keep making money. We have prevented them from doing so. So, like all cyber criminals and generally all threat actors in general, they will pivot, come back, try again, because it really is important to them to keep victimizing people to, pad their wallets, if you think about it.
I would add onto what Lindsay said is that it's not a cyber like vulnerability. The vulnerability is in the supply chain. The vulnerability is, you can create these things for $20 and you have this wide audience that you can sell globally until that gets fixed, until people say, okay, well, I'm really concerned about the device that I plug into my network. I want it to be something that I'm not concerned with. And so there's like a huge sort of communication and sort of learning here where I think people, if you really sat them down and talked to them and showed them what's going on, they don't want people committing crimes from their home networks and stuff, but they just don't know. They don't know what it's really important. They don't know what the risk is. It's really important that, we have folks like you that are doing these podcasts and talking about it, because it just doesn't get to the level of visibility. We had another, what was it, fish and chips that was around like shopping and stuff, and how these fake sites were up, and that, the actual, real news, wanted to do interviews on, but we haven't seen that same interest really with BADBOX.
It actually sounds like a supply chain issue. There's a lot of talk around hardware bills of material and software bills of material. I wonder, would something like that address this problem?
I think we're so far away at the $20 mark for SBOMs and stuff that it really wouldn't matter. Like, by the way, they would just stamp on whatever SBOM you wanted. Like, yeah, no, that wouldn't. What would, change this is people like, maybe the major people that are reselling these things say, we will not resell stuff unless it's past some level of certification that it's okay. Lindsay's mentioned the Play Store Protect a couple times. Like, Google does have devices that are certified that are totally safe to use. And so, until customers say, I want to use that device and not another, or the government gets involved and does something like they do with cars, right? You can't buy a totally unsafe car, supposedly, or you can't drive it, right? So they either do that, but, think of it's one car or two cars per family. Think of how many IoT devices an average home has, and who's going to fund testing and do, like, we're in we're in an area where it makes it easy for the fraudsters to continue to exploit this.
Then again, if we're talking about a $20 internet-connected toothbrush, nobody's going to care. They're not going to pay $50 for one that's been certified and run through the rigors of testing.
Sure. So one of the things that I want to highlight here is BADBOX 2.0 really does highlight how much more sophisticated these ad fraud and cybercriminal operations are getting. So we're used to all kind of seeing those more simplistic ad fraud operations where it's just kind of a bad set of apps or something like that. But, it is just one component of this huge cyber fraud ecosystem here. So we have the ad fraud, we have the click fraud, we have the residential proxy modules, we have the backdooring of these devices with more than one backdoor. So it's something where when we look at how cyber fraud is going, it is getting more sophisticated. And this is just one great example. So we can certainly expect to see campaigns of this level of sophistication in the future. So I guess that's partially what keeps my job super fun, but it is something that is certainly worth being aware of.
I think like with BADBOX 1, it was bad. The boxes did bad things, but the size was very different. With BADBOX 2, they're bigger and a lot badder. And, I look at this as, these are kind of like sleeper cells all over the world, just waiting for the bad guys to do whatever they want. This should be a big issue. The press should be interested in this. This should be something that people go, like, if there was a way that you could just get into every home in America or South America or whatever and commit crimes there, stab people in the backyards and stuff, people would not stand for it. But somehow, because it's happening in zeros and ones, it's okay. And what we're doing is we're setting up this amazing framework. We're part of it. We buy these devices for the bad guys to continue to persist and to continue to be effective. And there isn't really a lot doing, we've seen great, props to Google. They've done tons to try and shut this down, really out of the goodness of their heart, right? We've seen a couple of other folks, that have been, I think Team Cymru in particular, we mentioned the Shadow Server Foundation. There are a few folks that are going, hey, this isn't right, and we should do something to stop it, but it really needs more.
I'd like to thank Gavin and Lindsay for coming on the show and talking about BADBOX 2 and the problems that we have with the Internet of Things. Hey, if you're enjoying Error Code, tell a friend. I'm sure there are other people out there who like narrative information security podcasts. And I'd really like to hear from you. Go to errorcodepodcast.com to get more details. And tell me what you like, and even what you don't. I've got some great episodes coming up. We'll have more on Volt Typhoon, Salt Typhoon, and hacking utilities supply chains. Subscribe today. I don't want you to miss out.